thanks for coming to my talk. I'm going to be talking about deployment of Symfony applications. My name is Pablo. I live in the US, in Miami more particularly. I like sailing, take the elephant for sailing, it's fun. You can find me on Twitter. If you want to say anything about me or my talk, you can say it now. I'm not going to be able to reply. But I'm from Argentina originally. We take barbecue very seriously. So this is our barbecue. And this is another one recent on one of my trips. I'm working for a company in the US called Lighthouse Guidance Systems. We develop software for the education system. We use Symfony, Angular, and a lot of other cool technologies. So if you are interested, we are hiring, so come find me later. So we are a little bit behind time, so I'm gonna try to hurry up because there's a lot to talk about. So deployment. Wikipedia says that software deployment is all the activities that make a software system available for use. So anything that you need to do to make your software usable by your users, that belongs into the deployment part. It's very important, part of the life cycle of the application, but to me is critical. A lot of people start developing the application, designing the systems and everything, and then they leave the deployment stage for the very last thing. And then they find out that there's problems, they need to change the application, they need to change the number of servers, etc. So it's very important to start thinking about this from the very beginning. So it should not be an afterthought, okay? You should start planning early about this. It should be predictable. You should be able to start your process from the very beginning, do all the tasks that you need to do, and by the time the process finishes, you should be able to have a new version of your application running on your servers. And if something goes wrong in the middle of that process, it should stop before actually changing your system, your production systems. And the more you do it, the better it goes. Okay, if in your company you deploy a new version every couple of months, even every month, it's going to be a big deal. It's going to be a big event that you need to plan. You need to have everybody at the same time, etc. If you do it weekly, daily, even many times a day, then it becomes part of your daily routine, and I mean things are going to go smoother. So I like to put some tweets here. There's here a guy saying that we should not deploy on Fridays. Okay, I mean if you're doing it every day, why not Fridays? Why not Saturdays? Okay. So someone else replies saying, okay, there's 7 days a week. You should be able to do it any of these days. And then someone else said, we deploy many times a day. Okay, I remember reading an article about GitHub, and they deploy 1,000 times a day, which is quite crazy, but they do it. So when things go well, you have time to enjoy life, and you can go sailing to a place like this. And by the way, this is a pool in a resort in Chile, okay? I haven't been there, but it's definitely on my bucket list. So nowadays, we have a lot of these companies called PaaS, Platform as a Service, which they help you not worry about the platform. So you can open an account with them, you deploy your software, and everything runs quickly. So the first thing you need to do with one of these services, you need to open an account with them. Then you're going to be creating your application. If you use something like GitHub or a Git repository, you push the code, and then by configuring the service, the platform as a service provider magically deploys your application or your website, and everything runs without worrying about a lot of things. So, for example, Heroku is one of these companies, and I think they got it right. They're one of the latest to enter the PHP market, but they are getting it right. They they check your repository for a composer JSON file, and if they find one, they say, okay, this is a PHP project, so whenever I'm deploying this application, I need to install PHP, I need to do a series of things. But they go a little further. In the composer JSON file, you can define what PHP version you are going to use. So you can use PHP 5.3, 5.5, etc. And they even support HPM or hack. And then in the proc file, it's another text file that you need to create in your project. And there you define which web server you want. You want to use Nginx, you want to use Apache, etc. And a series of other configurations for your application. So then you run Heroku create. This is going to create your project into their servers. It's going to set up a Git repository where you can then push to this repository. And when you push, Heroku loads the project, finds the composer file, is going to install PHP, and then is going to run composer to install all the project dependencies. And when it keeps running, when it finishes, it's going to package your site, your application, into a file, and then it's sent to all the servers that they have. So by the time this finishes, it deploys your application, and boom, you have your Symfony site running on their servers very easily. If you start getting more traffic, then you can issue a command to increase the number of web nodes that you need, etc. There's a lot of things that you can do with this. And that's it. You just deploy an application easily. Any questions? We are done with the talk. So, no? I guess there's a lot of people here, so I should continue. So, there's many buts. What if the platform is not flexible enough for your needs? What if their prices are too high for you? What if they don't have servers in the region where you need your users to access the site? There's many buts. So let's check out how we can do deployment on our own in any provider, kind of trying to do the same things that they do. So let's look at some goals. So the first thing we want to do is we want to do one-click deployments. We need to be able to start our deployment process very easily by clicking one button on a web page or by running a command in our terminal. Then once we can automate that, we can start doing continuous deployment where we hook our deployment process with a continuous integration server or a testing server. And every time we push new code, we run all our tests. And if everything went okay, then we can deploy our application automatically. We should be able to do it anytime and anywhere, okay? Whether you're in bathroom, you're traveling, you are on vacation on the beach. If you have an internet connection, you should be able to run your deployment process. And anyone should be able to do it, okay? Well, maybe not anyone, but you should be able to create a process that is designed to be run by anyone in your team or in your company. So if you happen to be on vacation, someone else can take over it. They don't have to be an expert on the field, but they can run the whole process. And this is also good because if you have a team that has new members, those new members in the team, they may be able to do the deployment process. In fact, talking about GitHub, I think they allow pretty much anyone to do deployments. It's pretty crazy. And as I said before, it should be reliable. When you start it, if it finishes, you have a new version of your application. If something goes wrong in the middle, it shouldn't change your application at all. And you should be able to do rollbacks. You should be able to go back to a previous version because everyone writes bugs. So you should be able to do this easily. And I don't know about you, but I don't work for Apple. And Apple, every time they have a new product or something, they take down their website with a nice message, come back soon. My customers cannot live with this. So we should be able to deploy new versions of our site or of our application by not taking the whole thing down. And another nice thing about this is it should be reusable, not like this plug from the UK that you cannot use it anywhere else. So you should be able to create a process that you can take to a new job, take to a new company, and when you do that, if someone comes into the team, they may already know these tools that you're using, okay? So it's gonna be easier for everyone. And it should be scalable. You should be able to start with one server, and as you increase the complexity of the application, or you increase the number of you have more traffic, you need to increase the number of servers, so you should be able to easily do this. Let's check out some facts about deployment. Deployment starts with the developer, okay? You should be able to be developing your application as close as possible as production servers. So nowadays, Linux runs the majority of the web, which means most of us are going to be deploying our applications on Linux servers. So if you are developing on Windows, I'm sorry, but at some point you're going to create problems because something is different in Windows from the Linux servers. So at some point something is going to break. And the same applies for Macs. I mean, Macs are, natively they don't run Linux. You can, but I mean, why? But you need to be aware of these things. Always set up test and QA staging servers so you can catch any problems before you actually push code into production. You can use Vagrant to manage virtual machines so you can recreate the whole production stack in one computer like this one. But if your site or application is complex, you're going to have many virtual machines. So something to consider is to use Docker to use containers instead of virtual machines. And containers are like lightweight virtual machines, but instead of having many virtual machines, you have one virtual machine or one server running many containers, and they share memory, CPU, etc. So it's a lot leaner. Your development environment is going to suffer a lot less. And another thing I like to do is I like to automate the setup of my development environment. So when we talk about automating our servers, we talk about using tools like Ansible or Puppet or Chef to install and configure our servers, but we can take that idea and apply it to the development environment. So you can use something like Ansible and then Homebrew Cask, which is an extension of Homebrew, to install the software that we normally download in the Mac, like the DMGs, like to install Chrome or PHP Storm or anything like this. You can actually do all of that through the command line. And when we do that through the command line, it means that we can actually automate it. So by doing this, then our development environment may be similar or the same with the rest of the team. And then you can also apply this to many computers. So if you have a laptop and then you have a computer at the office, they can have the same software easily installable. So another fact is that success of the deployment depends greatly on the server operating system setup. Always automate things. Use things like Ansible or Puppet, Chef, Salt. There's quite a number of these. I prefer Ansible. It lets me do the job without having to spend months learning the tool. But once you automate your installation and configuration, then let's say you need a new server, you quickly run the whole deployment process and you have new servers running with exactly the same software as the other ones. If you have third-party software that you need to use, always create packages. Don't go into the server, download the source, and then compile and all of that. It's going to create problems at some point. And once you have these packages, you can set up your own repositories, so you can configure servers to fetch these packages from your own repositories, and then all your servers are going to have the same software across the board. Another fact, monitoring means uptime. Always use tools to know what's going on your servers. So again, there's a million tools here that you could use. Some of the ones that I use all the time are Ganglia, Cacti, Zabbix. There's many more. And when you do this, you can start seeing how your servers perform over time. And then if something really spikes, then that means that there's something there to watch out. And you can catch problems before they actually take down your applications. And we can take this notion further, and we can add metrics to our application. So by using Graphite, StatsD, and New Relic, and other things, we can actually measure how our different parts of our application perform over time. And most of our applications are going to generate logs. In Symfony, we have the logs directory where we have the production logs and other logs. It's common to go and tail the log, open the log, and watch what's going on, but use them wisely. Use something like Logstash or Heka to collect all your logs, send them to a central place where you can index them, and then you can search through them very, very easily. Let's check out some methodologies to do deployment. The first one I like to mention is the Vim style deployment. Okay, this is where you go into the production server, you run Vim, you open your file, and you start changing code directly. Who hasn't done this? Yeah, who has not done this? Okay, good. Oh, there's a liar over there. Everybody has done it at some point. So, but when you start doing this, you're going to break your application. Maybe you miss a semicolon or something, and your users are going to see a nice blank page, or, I mean, in the best case, a blank page, because maybe you can actually see the whole PHP error. So don't do this. FTP uploads are one of the most common ways to upload files to the servers. And how many problems there are here? So many. The most common one is going to be that, let's say we start uploading a Symfony project. We have like, I don't know, 100, maybe 1,000 files to upload. And by the time you start uploading files here, we're going to have several seconds, maybe minutes, before the process finishes. So when this is running, you're going to have new files, old files in the server all mixed, and things are going to break. So don't do these things. rsync may help in some things. I mean, the good thing about rsync is it uses SSH for secure connections. It just transfers the files that change over time from the last time that you uploaded the files. But again, it has the similar problems as FTP. Some people like to use source control. They clone a Git repository, and then they do Git pull every time they have new changes. Using build tools is a good thing. Use things like Ant or Thing or Jenkins to automate your deployment. So every time you need to run things, you do it the same way every time. And another thing you can do is, we talked about package repositories and things like that. You can actually create packages of your application with all the files inside of your web application. And then you can deploy these using the package manager of the operating system, like Yum in CentOS or apt-get in Debian or Ubuntu. And you can also use specialized tools like Capifony, Deployer. There's hundreds of these. And then finally, we can also use general IT automation tools like Ansible, Puppet, Chef-Salt, etc. And before, I used to use a lot of Capifony, but lately I've been using more Ansible. I like to use one tool that can install software that I need and can also install my web application in the same process. So regardless of the library or tool that you use to do deployments, there's a series of steps that we are going to be taking to deploy our web application. The first thing we need to do is copy the files to the server. Somehow we need to set server configurations. We need to maybe load database fixtures. We need to process and install the assets. And the assets are those JavaScript and CSS files that our application needs. We may need to warm up cache, and then we may need to enable the site. There may be other processes in the middle, but this is usually the most common ones. And then the subsequent times for deployment, we are doing very similar steps. Maybe some things change here and there. But whenever we are repeating all these steps all over the time, it means we can automate. And this is the main goal that we need to take from this talk. Anything that you do more than one time, you need to automate it. So let's look at some challenges. So the first thing, our deployment has to be secure. We always need to be using SSH-based connections. Don't store passwords or other sensitive information in source control. For this, you can use environment variables, but keep in mind that whenever you use environment variables, if you have a PHP info somewhere lost in your server, or you have something that prints environment variables, is going to be available for the users of the application. So be careful with this. Managing static files is a challenge. Always minimize and combine JavaScript and CSS files. In Symfony 2, we have been using Ascetic for a while. It's a good tool, but I think nowadays there's better tools like Grunt and other front-end specialized tools that we can use to do this. And when we minimize and combine things, we free up processing power on the server because we are making the client send less requests to the server or load less data, and things go much faster. This seems to be quite, a no-brainer, but believe me, I've seen servers without compression a lot of times. So always check that you have web server compression enabled, because you're going to save a ton of bandwidth and things are going to work faster on the client. And whenever we make changes in our JavaScript files or CSS files, it's going to be, if you don't use any versioning, you're going to notice that you're going to be, the client is going to be caching old JavaScript, and whenever things change on the HTML, things are going to look broken. So always add some sort of versioning system. Adding version numbers to links when you're loading the assets is a simple way, and Symfony/Ascetic allow you to do this very, very easily. And talking about Ascetic, the easiest way to do this is to run Ascetic on the server you're deploying this stuff. But this means that you need to install a lot of software to run Ascetic on every production server you're going to be deploying. And this is going to consume resources, memory, CPU. It means you need to install all this software. So it's always better to actually run this process locally or on a staging server where you can actually install the software, and then you don't have to install it everywhere else. Another good idea is to send or serve the static files from a subdomain or a CDN like S3. Things are going to work much faster. And let's see about file permissions. This is a very common problem where you upload files as a user, and then Apache or the web server runs as a different user. So things, at some point they're going to break. So one option is to run Apache or PHP with the same user that you are using to upload the files. Another option is if you use PHP FPM, you can configure it to run as a different user other than the web server. You can also create a deploy user that is going to be, you configure the web server to be in the same group, so they share some permissions. And finally, you can use setfacl to allow multiple users to have write access to directories and files. So these are all different ways of dealing with permission conflicts. And just keep in mind that there's no excellent solution for this. There's no most secure solution for this. Whenever you allow the web server to write to the server, you are opening a hole there that if you don't take it seriously, you can have serious problems. Like WordPress, for example, is very popular for allowing users to upload files, but then there's been bugs where anyone can actually upload files, and they start uploading PHP scripts, and they do all sort of nasty, very nasty things. So be careful here. So one option for dealing with this is use external services for writing files. So if you have uploads in your application, put them on S3 or some other external service, and then you have a read-only installation that is not going to be impacted by this. So some common pitfalls, like case-sensitive file systems, is one of the most common problems, where you have a class name with some case in there, but then the file name has a different case, and when you run it on production, it's going to bomb. Now, Symfony has a check on development mode that's going to show you a message, but if you don't catch this early on, you can be in trouble. Configuration differences. Fabian talked about the ICU problem. This is also very, very common, where you run a version of a library here locally, then the server has a different version, and when you upload the things to the server, things break. You don't know why. It's because there's differences there. Outdated third-party software is also a problem. Always try to have the same versions of the software, updated versions, just locally in testing, staging, etc., and production. And nowadays, we rely on GitHub a lot to do deployment. And when GitHub goes down, we find out that we cannot deploy. So an option is to run a Git daemon, a Git server, and you can do this very easily by running this command on one of your machines. And then in your deployment process, you clone from this repository from this server that you can control. And another option, great option, is to use Torrent Proxy, which is a service provided by Jordi from Composer. So check it out, it's super cool. And by doing that, you also support Composer and the open source ecosystem. So let's check out some examples of how we can deploy Symfony apps. If we create a hook, hook.php file that when we run this, we actually do a git pull of our repository, we can very easily create a continuous deployment system. For example, you can go into GitHub, and they have these hook systems where whenever you deploy or you push code to GitHub, they actually hit a URL. So in this case, we hit the hook.php. So every time we push code, this code is going to end up in our servers because we are pulling. This is very, very good for simple projects, simple websites that you just need to get it out of the way. It's going to save you a lot of time. So Capistrano and Capifony are one of the most common ones. Tools to deploy Symfony applications. Capifony is Ruby-based. It has a lot of extensions. It is simple to install. You just run gem install Capifony, and if you have Ruby installed, then you can start using it. Then the configuration is fairly simple. You need to set some variables like the application name, the path where you are deploying. You set the user that you're going to be connecting to your servers, the repository, and then you can list all the web servers or the application servers that you're deploying to. And then you run cap deploy setup, and this is going to create in your server a directory structure where your application is going to be installed. So you're going to have a releases directory where every single deployment is going to exist in one directory inside releases. And then you have a shared directory where you can have directories and files that are shared across different releases. So to deploy, you just run cap deploy. And whenever it's running, it's going to create this directory with a timestamp with all the application inside. And if everything goes according to plan, then it's going to create or update a symlink that is going to point current to the directory that we just deployed. You can also do migrations and rollbacks. But what I found was that Capifony worked fairly well, but anytime I needed to do things, more complex things, I had to write a lot of Ruby code, and I don't really like Ruby. And then I also found that every time I updated Ruby or something, it broke. So I spent like a lot of minutes trying to figure out what's wrong with it when I was actually wanting to deploy my application. I didn't want to be wasting my time with Ruby and Capifony. So I started using Ansible for managing my servers, and I decided, okay, why not use Ansible also for deploying Symfony? So in Ansible, the process is going to be very similar. We need to define an inventory file that is going to list the servers that I need to apply or deploy my application. And here, for example, we have two groups of servers. We have the web servers and the database servers. And you can also here, in one single line, you can define 50 servers that you want to deploy to. So with a very simple configuration file, you can have a large inventory of servers. And you can also do dynamic inventories by creating this inventory dynamically. You can do a lot of really cool things. And then we need to define a playbook. A playbook is a YAML file. So for us in the Symfony world, we are used to dealing with YAML files. So this is going to be very familiar. We say, okay, we are going to run these tasks for the web servers. We are going to define some variables, and then we list all the tasks that we need to run in our servers. We can also reuse these tasks by creating roles. So a role is just a collection, it's like a bundle of tasks. So we can create a role with all the tasks, and then we can reuse it in different Symfony projects. All we need to do is tell, okay, we're going to use this role, and we specify the variables that configure this role, and then we can use it. And then to just run our deployment process, we just run Ansible playbook. We specify the inventory file and then the playbook. And when it runs, we're going to see that Ansible is going to display each task, and it's going to show the result of each task with a different color. So people on the back are not going to see this, but if it's green, it means that the task ran okay and nothing changed. If it's yellow, it means that it ran okay and something changed. And if it's red, it's because something went wrong, and Ansible is going to stop that process before it actually changes the application, the live site. Then there's some other utilities that we can use to do deployments. There's Fabric, there's a lot of PHP ones. These are just for reference. You can use any of these. You can learn from these. There's plenty. Let's check out some complementary tools to do deployment correctly. So I was talking about creating RPM packages or dep packages with our application. And if you've created RPM packages in the past, you know how painful this is. So with FPM, this is very easy to do. You just install the software, then you run one command with a set of parameters, and it's going to create the RPM package or the dep package. And here you can not only define the version and the name of the application, but you can also define dependencies. So let's say your application needs the PHP extension, I don't know, IMAP. You can define it here, so whenever you install this package, you're gonna the package manager of the operating system is going to install these dependencies for you. I was talking about stats, D, and graphite. This allows you to create metrics in your application. So for example, here we are graphing the number of logins that we have in our application. So for example, let's say we deploy something and the number of logins drops dramatically. It means that we probably broke something. So this allows you to do very cool things. For using in PHP, we can use the statsd PHP client. And then we just need to configure in our application, we need to configure the server where we are going to connect. and we can use UDP to connect to that server, so it's not going to affect the performance of our application. And then we can start creating metrics, so we can start timing things in our application, like controllers or sections of our application. You can create counters, so you can count how many orders you're getting, or how many users are logging in, how many invalid logins there are, so you can see if people are actually trying to abuse your system. And I mean, there's so many uses for this. You can also collect memory usage. And then with this, you can then start creating graphs and combine graphs. So you can see, okay, my application is using this memory when this is happening, etc. So if you have multiple application servers, you can send everything to one central stats server. And then with Graphite, you can create these graphs that I was showing. And then Grafana is another tool that allows you to create nice dashboards. So people that are outside of your IT team can actually look what's going on with your application. Talking about logs, using logs wisely. Using Logstash is very easy to collect all the logs from different servers and send them to a central location like Elasticsearch. And then when you do that, you start indexing the logs, so you can search them very easily from one central location. You can also configure Apache to generate logs in JSON format. So when you do that, Logstash is going to collect those logs, and it's going to, every Apache log entry is going to be a JSON document where you have the status code. So now you can start searching or querying for 404 errors or 500 errors, etc. So, and then you can use Kibana, which is a really nice tool that connects to Elasticsearch to do searching or to do graphs on your logs. So again, we have multiple application servers running Logstash, collecting all those logs. We can use Redis to use as a central queue system. So you can send everything to Redis, and then Redis is going to send everything to another Logstash instance where you can apply filtering, or you can apply conversions of the data that then you finally store in Elasticsearch. So summarizing, this is what we want to accomplish. We want to have the developer push code to GitHub, then GitHub notifies Jenkins, there's changes, Jenkins or another continuous integration server is going to run all the tests. It's going to build an artifact combining all your files into one file that then we can send to the different servers that we have, send them to the QA the systems to run the integration test, and then we can use Ansible to update production. And whenever production is updated, we actually send notifications to the developer through email, SMS, chat, etc. So what's the future of deployment? In my opinion, the future is containers. Okay, you probably heard a little bit or a lot about Docker, and I think this is the future, because Docker allows us to create these containers with our application inside. We can start extending containers. So we can start with a container that is running Linux, and we extend that, and we create a container that is running Apache, and then we extend that, and we have a container that is running that includes our application. And once we have that container, we can create an image that we can deploy to one or hundreds or 1,000 servers. And you can do this by actually deploying your container locally in a virtual machine, but you can also deploy these containers in more than one server, in many servers, across providers. You can deploy in Amazon, in Linux, DigitalOcean, anything that actually supports Docker or Linux, you can do it. And you will have the same installation across multiple providers. So I think Docker is the future. I think there are some people already using it in production. I think it may be a little bit early because it's still moving very fast, things are changing, but keep an eye on it. So final thoughts, stop using FTP if you are. Plan early, so start designing your deployment strategy, your procedures early on. Do it very often. Do it as often as possible. You're going to lose whatever fear you may have. Add monitoring to your applications, to your servers, so you know what's going on. And finally, automate. Anything that is repeated has to be automated. And now we did finish. You have any questions? I think we don't have much time. Oh. So if you have any questions, feel free to get me. And please leave feedback so I know if there is anything that needs to be improved. Thank you.